Hi, welcome to the fun probability problem solving sections. And today we're going to work on the second part of this problem here. So the first part is we proved that when A is a subset of the B, and the probability is 3/4 to the nth power. So the second part is just follow the same thinking as the first part. We want to prove when the A intersect B is equal to the empty set, what is the probability for that? And in here, I want to mention, I strongly recommend that you watch the video for the first part. And it explains the reason why we do the certain way. And I think if you watch the first part, and then the second part definitely going to make a lot of sense. And all right, so I would recommend you to watch the first part to see the brief examples, how that work, and what is the thinking process behind it. All right, okay, now let's go ahead and start. And since we already covered the first part, I'm not going to show you the examples. And so we just go directly to the proof part, okay? So let's go to the whiteboard here. Okay, so here is the whiteboard here. Okay, so now we want to prove the probability. What is the probability A intersect B when they equal to an empty set? Okay, so we can use the same thinking. We say the partitions, right? So we'll say the summation. So the probability A intersect B equal to the empty set given, like we did on the first part, let's see how many elements in the B. So we say given that elements in the B is I, right? Then times the probability of the elements of the B is I here. Okay, so the I is from 0 to n here. So the first, this is the same. The probability, the B events have I elements. These probabilities here, just like we did the first part, is 2n, right? So this is n to the i's here, okay? And now in here, let's take a look here. So let's do the breakdowns here. So when the probability, let's take a look at one single one here. Probability A intersect B equal to the empty set, when the number of the B have I. Okay, so these ones here, really we can have 4 different situations, right? So because the number, so have I elements, so total here, this is n elements, right? So when the B have I elements here, so in order to B intersect to be the empty set, right? That means the A has to be over here. Okay, so that is the, so that's why they will intercept will be the empty sets here. So we will have the situation is n minus I right now, correct? So it's n minus I is this pink area. So for n minus I, then the A can take 0 elements. And the same things here, we said n minus I, A can only have 1 element. Then the same things here, this is n minus I, A could have 2 elements, right? No, it's all the way to n minus I, okay? And to the n minus I elements, right? So they can have many these situations here. Okay, so now we can rewrite it. So, okay, so this one is just like we did for the first part. So we say this is I equal to 0 to n. And this part here, this part, we can write it as the summation, like here, right? So k from 0 to I, right? So then here, this is a 2n, and then this is the I take a case here. All right. So it's I take a case here. Then times this probabilities, right? So times this is the 2n, and this is n take I here. Okay. So so now, for this ones here, so let's just take a look at what we did. Let's break this one out. Let's see. So this is the summation k equal to 0 to the I, and this is the ik, and over the 2n's here. So we know from the part 1, one way we can do it, we write it as the binomial expansion. So this is 1 to the k's power. Then here, this one's here. I'm sorry, this is n minus k. N minus I here, right? So we just say the n minus I here. So it's n minus I. And so here, let's take this one out. This is n minus I. All right. And then in here, I'm just so still in the part 1. So this should be n minus I. And so here, this one should be the n minus I here. Okay. So now I'm using the binomial, so it's 1 to the k. Then also this could be the 1 to the n minus I minus k, right? So the binomial expansion. So what is this one equal to? This equal to 2 to the what? 2 to the n minus I. So these terms here, so this will be equal to 2 to the n minus I to the 2n. So what is this one will become 2 to the i's power, right? So this green one will be 2 to the i's power. So now we can say here, this is the summation I from 0 to n, and this is 2 to the i's power, and the times here, this is 2 to the n, and this is the ni. Okay, so this is the ni. So we do the same thing, and let's move the 1 over 2n out. Then this is the summation I from the 0 to n. Then in here, this is n factorial, I factorial, n minus I factorial. And this 1 over 2i, so I can set this 1/2 to the I. Then by using the binomial expansion again, so this one's, I can write it here, right? So this 1 to the n minus I. So what do we get? So what do we have over here? This is the binomial expansions, right? So this blue one will be equal to 1 plus 1/2 to the what? N's power. So this is 3/2 to the n's power. And now in here, this is 1 over n times 3/2 to the n. So this one will be 3 to the 4th to the n's power. Okay, so it's pretty fun and kind of easy if you understand the part 1. That's why I kind of strongly recommend you to, if you did not see the part 1 video, I strongly recommend you to go to see the part 1 video, and then you will understand, why I, do like choose the n minus 1, 0, 1, 2, those things. From the part 1 video, you will get a good understanding. So then that's why this part 2, the proof is quite easy. Well, that's fun. And I guess I will talk to you to our next problem then. Okay, bye. Have a good day.